All right. So has anybody got a chance? Hello, Arya. Hi, here. Okay. So I was just curious to know if you guys got a chance to see what are the topics that we're going to cover today. Nobody? Okay. So we will continue with Unit 4 that we were doing, and the topics that we're going to cover would be evaluating functions, composite functions, isolating quantities, and solving quadratic equations. So solving quadratic equation is something that we have done in the past. We'll probably just run through that quickly so that we are keeping pace with what we have in Unit 4. And then the last topic is linear and quadratic system of equations and solving them using algebraic approach versus using graphs. Hello, Ritika. Okay. So here I heard from your dad that you'll be starting coming to the class by mid of September.
Yes. So
okay.
yeah.
Okay.
Once the temperature goes a little down.
Okay. Yeah. No, that's a good idea.
Yeah. Me and Shravan would do that. All three of us.
Okay. Okay. Cool. So hi, Nanya. So I think we have pretty much everybody whom I was hoping to be in the class. So Ritika has also joined, and I think the only person we are missing is our Rutvik, Shravya, and who else? Rutvik, Shravya, and in the classroom Praneet. So all right. So let's get started. So let's start with the, first of all, tell me who all is not in the WhatsApp group. The WhatsApp group for SAT prep classes. I think Arya is not in the group yet.
Oh, I am.
You're there?
Yeah.
Okay, you're there. So basically, since, for most of the WhatsApp group, for the younger kids, it's mostly the parents who are there, but since you guys have your own phones mostly, so I would suggest you all join that group so that you get first-hand information, and it will be easy for me to easy for us to communicate among ourselves. Okay, so let's start with the first topic. Let's talk about the first two topics: evaluating functions and composite functions. Now, I am pretty sure most of you would be knowing about it. We'll just brush up the concepts and see if there's something that we are learning new, or that is something that we need to be explained. So when you say evaluating functions, let's say there is a function called function of x equals x squared plus 2x minus 7. So when you say evaluating functions, what do we mean? Anybody? What we are supposed to do as part of evaluation of functions? And trust me, any answer is not a bad answer. Okay, so it's okay to take a punt at it. Anybody? Nobody? And I would suggest you guys to be more, what do you call it? I would want this class to be more interactive. So when you guys answer something, that gives me a feeling that everybody is ready to participate. Okay. So okay, let me kind of solve the riddle. If in case you are hesitant to say something, when you say evaluating a function, you evaluate a function for a given value of a variable. Now, if you look at this function of x, meaning this is a function of x which is representing the relationship of x, which says x squared plus 2x minus 7. And when you evaluate a function, you evaluate this function's value for a given value of a variable. So let's say if you say evaluate this function x for x equals to 2. Does it make sense so far? You evaluate a function for a given value of the variable that you have in the function. Okay? Or the expression, whatever you call it. So if you say evaluate this function for value of x equals 2, can somebody tell me what will be the value of function of x or function of x equals 2?
Sir, it's 1.
Is 1. So you will substitute 2 in place of x. This becomes 4, this becomes 4 minus 7. Yeah, that is. So basically, it's a very easy one, and I'm sure most of you have learned this in the past. It's just a matter of putting your thoughts around it. So you will see that there are a lot of questions around this one in Khan Academy also. When you do this unit, you evaluate function for given value of for x. Let's say if you have another function which says function of x equals 2x plus 7. I don't know why I'm so inclined towards putting a number 7. Let's say 2x plus 18. Evaluate this for x equals 2, x equals 4 and 6. What you will do is you will just put the value of x in this function, and that is what will give you the value of this one. So that's all about evaluating a function. Anybody have any question about this easy peasy concept?
No, sir.
No. Okay. Now let's make it more interesting. So when you say function of x is something, let's say 5x squared plus 3x minus 12, and function of g is 2x plus 7. Again 7. My bad. Let's say 2x plus 3. Now if somebody says find out function of g of when somebody says find out function of another function, for x equals, let's say 5, how will you go about it? This is called composite function, meaning a function of function. So we know function of g is given as this and function of x is given as this. If I ask you guys to find out the value of this composite function for x equals 5, do you guys know how to do it? How to deal with composite functions?
Yes, sir.
Okay. Can somebody help me find out the value of this composite function of g of x for a value of 5 when these two functions are given? Can you guys try solving it? I just want to see again. I don't mind teaching it. I'm just trying to see if everybody understands it by themselves or if there's something that I need to explain. So you guys have, let's say, 5 minutes to find out or evaluate this composite function for value of x equals 5. And as I keep saying, I don't care about the answer. So once any of you say that yes, I have been able to solve it, I would want you to explain that to me from a process point of view, so that at least we are sure about what we are doing and how we are doing. Can I assume everybody is doing it?
Yes, sir.
Okay.
Yes, sir.
Okay. All right. Yep. And once
Sir,
anybody,
got it.
you got it. Okay.
Yeah.
I'll probably give 2 more minutes so that I have few more kids here ready with the solution. And again, excuse me guys if I call you guys kids, because that's how I'm going to treat you always. I'm just waiting for 2 more of you to say yes, I got it, and then I would let Vaibhav to start and explain me what did he do, and then you also got Arya.
Me too.
Okay.
Yes.
Okay. So I'm sure I'm about to hear me too from many of you. So okay, let's see, Vaibhav, if you have to explain this to me, as you being the teacher, I being the student, what did you do for solving this problem?
So, first I did g of x.
Mm-hmm.
So first I solved g of x,
Mm-hmm.
and then after the getting of the value of g of x, I found f of x.
Okay.
So that's the process.
Okay. Wonderful. Now, Athar, I would want you to explain me. I believe you also have done the same way, correct?
Yeah.
So what was the value of g of x you got here?
13.
13. So basically, as Vaibhav said, you did the same thing. You took value of x equals 5 and substituted it here. And that's what gave you g of x equals 13, correct?
Yeah.
And then Arya, what did you do with g of x as 13?
Can you repeat that?
No, my question too was, I'm just making you guys, compliment each other. So once Athar said that he got g of x as 13, what did he do to do the final solution of this problem?
I don't really remember how to do it, but I multiplied f of x and g of x.
Okay, that's one approach I'm hearing. Anybody else? Anybody else can explain me? Dhanushri or anybody? See what's up? Anybody? That we got g of x as 13. Now we have to find out function of g of x. What did we do?
Now you need to find the.
Sorry?
Now you need to find the f of x.
F of x for x equals to 13, right? So
Yeah.
this gave you the exact value of 13. G of x gave you 13 for x equals 5. Now you will just forget about g of x and you only know this as function of x where x equals 13, okay? And you have this function already given to you, yeah? So when you look at a composite function or a function of function, it might look a little tricky to begin with, but it's as simple as peeling off the onions, okay? Everybody knows how to peel off the onions, right? You can take out the layers one by one. So that's exactly what we do as part of composite functions. I mean, this was an easier problem that we had to deal with. So just for everybody to be on the same page, what did we do? We knew that we have to find out function of g of x. And what is g of x? G of x is this. And here we have to find it out for value of x equals 5. So first thing we did, as you guys told me, we found out the value of g of x for x equals 5 by substituting x equals 5 here. So we got g of x as 13. Now in the next step what I will do is, now my job is easier. I have to find out function of 13. And we know what is the formula for this one. So wherever I have x, I will replace that with 13. 3 into 13 plus, minus 12. So this gives me 13 square is 169, 5 into 169 plus 13, 3 is 39 minus 12. And then I will solve it for this one. So this is one of the easy problems that, or this is the maximum level of complexity that you guys will end up dealing with. But it might so happen somebody will say, okay, fine, find out the composite function like this. Oops. Function of k of function of g of x, let's say. So now here you see, this is one function, we are finding function of this function and then finding function of this. And then you will be given, okay fine, g of x equals, let's say, 2x squared minus 1. K of x is nothing but, let's say, 3x minus 17. And function of x is equals, let's say, x squared minus 24. Even if it looks very complicated to begin with, you will go step by step, simplifying this. First, I don't like function, I want to convert that into a constant value. So I'll start from the innermost bracket and convert that function looking thing into a number. And I have a formula already. Let's say you have to solve it for x equals to 3. So first thing I will do is find out g of x. That gives me some value. Let's say for this x equals 3. This becomes 2 into 3 square minus 1. So 9 into 2, 18 minus 1, 17. So this became function of k of 17. Now we know that k of function of k gives me this formula. So what I will do is, let me knock off the function of k and make that as, so we know that k of 17 would be equals this one, 3 into 17 squared minus 17. Okay, so this becomes 3 into, 17 I'll take out, 3 into 17 minus 1. So this becomes 51 minus 1, 50. So 17 into 50. Whatever it is, 650. Yeah, 650. So we got k of this as 650. So now what we have to do is find out this gives me 650. I think 17 is 65. Yeah, 650. It is a very simple function now. So basically, you have to just peel it off one by one. And always look at any problem that you deal with, your only attempt has to be to simplify them. More you simplify, easier it gets, and the pressure that we deal with by dealing with anything cryptic like this becomes easy by going step by step. So other thing, whenever you are trying to solve it, always use your scratchbook or your notebook, whatever you are doing for doing the calculation, to write this story, okay? Always write this story, okay? So if I got this, so what is my value of g of x? G of x for x equals 3. Okay, I found it. 2 into 3 square minus 1 is 17. So I got g of x is 17. Note it down. Don't rely much on your mind math, because you might lose track of it, and then it might be difficult to trace it back. Now I got this one. So now what is k of x? K of 17. Sorry, k of 17. So k of 17, I know k of function of k of x is 3x square minus 17. So okay, so 3 into 17 square minus 17. I write it like a story always. So that way it's very easy for you to go back and see where you have gone wrong, if you did, right? That helps you with a review. So always do that extra hard work to write that story so that it's easy for you to go back to this one. So now we looked at two nesting inside the composite functions. It might so happen, the examiner gets a little more creative and gives you 5 levels of function also. Even if it looks 5 levels, it's as simple as going step by step. So you keep breaking it down, and then you'll be able to solve it without any problem. So that's all about evaluating functions and composite functions. Any questions so far?
No, sir.
Okay. So my request to you guys would be, while we do a lot of fun activities in the class, but after the class, spend 30 minutes to go through the unit test on Khan Academy and do some practice, because I might just give you the conceptual overview of how to do things, and when you actually do those problems, you would know whether whatever I taught was enough or not. If there's something missing, you can always come back to me saying, sir, this part we did not cover, can you explain that? Okay. Or if you think that you know it better than others in the class, you can yourself say, okay, fine, we did not cover this part while we were learning this one, so this is something that I wanted to share with you guys. So start sharing more among yourself. Okay. Trust me, this is your best platform where you all can get benefited from each other. Okay, use that. All right. So this is about the evaluation of functions and composite functions. Any questions so far? Any questions? And I might call out the. Okay, no questions. Isha, Heer, Ritika, Shravya.
No, sir.
Okay, okay. Shravya is there, right, in the class? Or she's not? I see Ritika is there. Sunarka is also there. Yep. Hey, Sunarka.
Hello.
So, everybody able to follow so far, right?
Yes, sir.
Okay. Alright. So, let's go to the next topic. Shall we? What is the next topic? Next topic is isolating quantities. And again, this is something that you all would be knowing it already, but I will just quickly touch upon the concept so that we call it separation of concerns. Meaning, let's say there are 5 problems to solve. You don't want to solve all the problems together. You want to solve them one by one. So that way you will be able to evaluate how you are progressing, where you have enough information, where you don't have. So let's look at this situation where we talk about isolating quantities. Now, again, don't laugh at me if I am teaching you guys something very simple and silly, okay? Let's say you have an equation like 5x plus 2y minus 17 equals 82. You should try using this one equation to solve this whole thing. First of all, you cannot solve it, okay? You have 2 variables and only one equation. The thumb rule is you have to have as many equations as the number of variables. If you have 2 variables to deal with or solve for, you need at least 2 equations. So with this you cannot solve it. That's given. So the first thing that you will say, okay, if I ever ask you guys, okay, solve it for x and y, you'll say, sir, I'll not solve it because you have given me only one equation and with 2 variables. There's no way I can solve it. So then you will say, okay, fine. We have an agreement that yes, your ask is valid. So you need one more equation. So let's say 5x minus 13y equals 80. Now you have 2 equations and 2 variables. Now you should be able to solve it. A very simple scenario. Now how will you go about it? How will you go about solving it? This is where the separation of concern or isolating quantity comes into picture. What approach you will take is, you will try isolating things. You would want to isolate x and y in a way that you can look at them independently. Let's say if I give you an equation like 5x plus 225 minus equal to, let's say, 17. If I give you an equation like this, I have one equation, one variable. It's very easy to solve. You will get all the constants on one side, the variable on one side, and then you will isolate, right? So you will say, okay, fine, I'll get all the numbers on one side. This guy goes here, it becomes minus 25. And then I have 5x equals minus 8. So now, again, so here what did you do? You first isolated different types of terms. This was a term with variable, this was a term with constant, this was a term with constant. So you moved all the similar terms on one side and you isolated them. So you isolated the numbers on one side, the term with a variable on one side. And now again you have you have come to a point where you have a term with constant and variable both, and this side you have only a constant. So again you will isolate. You want to isolate the variable on one side. You will say, okay, quarantine. I don't want to see x with any number here. So this guy moves downward from here to here and it becomes 8 by 5. minus 8 by 5. So what did we do? This is what is isolation, right? We isolated the variable on one side and numbers on the other side, so that way we are keeping them separate. We are separating, it's called separation of concerns. This is one type of concern we are dealing with, this is one type of concern, and then we are solving it. Same way, here also when you look at the equation, again, this is what you have. What you want to do is, you want to isolate them in a way that you don't have to deal with too many variables simultaneously. Here you have two variables, here also you have two variables, x and y. What you want to do is, you want to find out what is the value of in terms of y, value of x in terms of y. So let's say if I pick up this one, okay, I should have kept a little different. I have, let's look at the value of x in terms of y. So I'll move everything to the other side. I'm just keeping x on this side. So 82, this minus 17 becomes plus 17, and 2y becomes minus 2y. So I got, this is 82 plus 17, 99, minus 2y. So 5x equals this, or x equals 99 minus 2y divided by 5. So what has happened is, now I can see there is a relation between x and y. So if I substitute this value of x here in this second equation, what will happen is, it will become an equation with only one variable, because here the x is again in terms of y, and this is already y. So now what will happen is, I will have one equation with only one variable. So if you look at this, so here instead of x I will write 99 minus 2y divided by 5. This was the value of x we had got in terms of y by picking this equation and isolating the terms. And then minus 13y equals 18. Now you guys anyways know that, okay, I have one equation with only one variable. From this I can find out the value of y. This is the same technique called isolation of quantities. You are isolating the quantities in such a way that you have lesser number of variables to deal with. When you have one equation with one variable, you are isolating constants and variable, so that you can get the value of the variable in terms of constant or number. If you have multiple variables, you are isolating one variable as a byproduct of the second variable, so that you can substitute that in the second equation and you can find it out. So this is one way of solving it, right? I mean, everybody knows it. I was just kind of reiterating this. So this is nothing but simple algebraic operations that you guys would have mastered by now. I was just kind of trying to relate the concept. So this is one way of solving it. This is how you are kind of finding the value of x in terms of y and substituting in the second equation, so that you have one equation with one variable and then you can solve it. And once you find the value of y from this equation, you'll again go back to the first equation and substitute the value of y. Then you will have only x and some constants. So that gives you the value of x also. This is one approach. What is the second approach? Anybody remembers? Let's say if I have the same equation, 5x plus 2y equals to 18 and 3x minus 6y equal to 22, let's say. One approach we found that we picked up one equation and isolated x and then got the value in terms of y and substituted that value in the second equation. This is one lengthy approach. There is a shortcut also. Does anybody remember what is the shortcut approach or the second approach?
So you need to do the sum of both equations.
Little louder.
You need to do the sum of both equations.
Okay, if you just go and sum it up, what will happen? This will become 8x minus 4y equals 22. So this became another third equation with two variables. Is it helping?
No.
Right? So here, I mean, you were going the right direction. You probably missed one important point. Again, the objective is the same. Objective is simplifying things. How I want to simplify things, my end goal is to get an equation with one variable. So what we can do? We can add the equation, subtract the equation, or we can multiply the equation, whatever helps. Here, if you look at it, this is 5x and this is 3x. Let's say I want to knock off x. How we can do that? If I multiply this equation with 5 and multiply this equation with 3, okay? And then I will say, I will subtract this equation from the first one. Now this is getting nice, right? So this equation is multiplied by 3. What this equation became? 3 into 5x, 15x, 3 into 2y, 6y, equals 3 into 18. 18 3 is 54. Okay? Now, we are multiplying this equation by 5. So, I'll keep the subtraction part later on. But here, 5 into 3x is 15x. 5 into 6y minus 6y. This is 30y. Equals 5 into 22, 110. Now we are subtracting. So, subtracting here, minus. This becomes minus plus. And this becomes minus. Now you see this. This gets knocked off. What you are left with is 6y plus 30y is 36y. Equals 54 minus 110. This becomes minus 56. What you got? Y equals minus 56 by 36. So you got an absolute value for y, and you can pick this value and substitute in any of the equation to get the corresponding value of x.
The reason right after the 3x minus 6y, because of the light, I can't really see it. Like, I just see a 2.
22. This is 22.
22?
Yep.
Oh, okay.
So see, the deal is this, that when you have two equations, you don't enjoy solving an equation with too many variables. And that's not a prescribed approach either. Your objective is, your goal is to make sure that you do whatever magic you want to do in a legitimate way to get to an equation which has one variable and constants. And that is what will help you get the value of this. What we did here, okay, 5 and 3. Or you could have chosen second option also. Okay, fine. Here I have minus 6y. Here I have plus 2y. How about we multiply this equation by 3 and just add these two guys. When I multiply this equation by 3, this becomes 6y. This is minus 6y. When I add them together, plus 6y and minus 6y nullifies each other. And then I'll be left with only an equation which will have x and a constant. Yeah? So now if I multiply this by 3, this becomes 15x plus 3 into 2, 6y equals 18 theta 54. And this equation remains as is. We did not touch this step. Now, we can simply add them. If you add them, these two guys get knocked off. What you're left with is 15 plus 3, 18x equals 54 plus 22, 77, 76. You got the value of x. So, your only objective is to do whatever trick you want to apply without tempering the relationship here. Let's say if you just say, okay, I will add plus 2y here. No, that will not work. You can multiply, you can divide, but you cannot just add any value in between. That will kind of temper the relationship. See, when you look at an equation, this is nothing but a relationship between x and y. Okay? So here, this says that this is the contract that we have between x and y, which gives me this value. So if I increase the value of x, my value of y will decrease, so that in total I get 18. If I decrease the value of x, the value of y will increase to get this final value. So this is a contract, this is a deal that you have between these two variables to get this outcome. So you have to make sure that you are not breaking or breaching the contract. You can multiply, you can divide, but make sure that you are not adding anything in between to get to a simplified equation. That's the only word of caution that you have to apply. Are you guys with me so far?
Yes, sir.
Yeah.
Yes, sir.
Okay. So again, I use the fancy word contract. Yeah. Now let's do a double click on that word contract. If you have any equation, let's say you have an equation, let's say x squared plus 2y plus 17, or this equals 72. I have special affinity for the word 7. See, every equation I write, there's a 7 in between somewhere. I don't know why. Now, when I have this equation is a contract, is a deal between x and y, if you look at it that way. Says square of x plus 2 times of y will give me 72. You decrease the value of x, the value of y increases to get to this. Increase the value of x, this value decreases because your end result has to be 72. So this is a contract. So that is why I was saying that, okay, if you multiply this, what happens is, you're saying that x squared plus 2y equal to 72, that means 2 times of this value will be 2 times of this value. That's why you're multiplying. Or 1/3 of this value will be equal to 1/3 of this value, right? It's the pricing system that you see in Walmart. It says 1 pound of let's say a pound of potato is coming for, let's say, $2. That means if you are taking half a pound, you will pay $1. 1/4 of a pound, you will pay 50 cents. But it will never become 2 pound of potato equals $6, because this is a contract. You are saying this is a rate. If they say, okay, 1 pound is for $2, 2 pound is going for $6, that means somebody is cheating us. Somebody is breaching the contract. Somebody is not honoring the price. Same way here in the equation also. You can only multiply. Say, okay, half of this will be half of this. 2 times of this will be equal to 2 times of this. It's a contract. This is a relationship between these two variables. I know it's an extra information, but I'm just trying to inject this concept so very deep that you don't have any second thoughts. Are you guys with me so far? Is it making sense? Is this analogy helping you kind of inherit this concept?
Yes, sir.
Okay, cool. All right. And some of you who are not speaking, I'm assuming they are also saying yes only, right? Sunarka, Isha,
Yes, sir.
Dhanushri, everybody?
Yes,
Yeah.
sir.
Okay. Okay. Because I don't teach for one child, I'm teaching for each one of you, right? So I'm just trying to make sure that everybody is with me. All right. So we talked about what are we talking about? We talked about the see, I'm kind of struggling with what I talked about. Evaluating functions, composite functions, and isolating quantities. And while isolating quantities, we just looked at some of the basic concepts where if I have two equations, there are a couple of thumb rules that we have to keep with ourselves. If ever you come across a scenario like this, somebody says solve 2x plus y equals 33. You cannot solve it. There are two variables, one equation. No ways you can solve it. Okay. This is just giving you a contract. Okay, if x is increasing, y will decrease. If y is increasing, x will decrease. This is just a contract. But there is no fixed value. There is no one solution. There could be multiple solutions. That is why when you use this for drawing on a graph paper, you will get a line like this, a linear equation. This is a linear equation. It will draw a straight line for you. And every point on this line will satisfy this condition. I mean, I'm not saying that this is the right line for this equation, but if it was, then every point in this line, you take the x and y coordinate and add them together, this is what you will get. That is why every point on this line is satisfying this condition. Okay? So this is just a contract. You have not got one solution, you have got so many solutions. There are so many combinations of x and y that you will get by one equation. So if you have to solve it for x and y, meaning you have two variables in an equation, you would need at least two equations. It doesn't mean the second equation has to have two variables as well. You can as well have two equations like this, and you can still solve it, because you will get a value of x here, substitute that value here, and you get the value of y. But you have to have two equations for sure, and both the equations should cover these two variables only. What if somebody says, okay, again you have the same deadlock, you cannot solve it. You have two equations and three variables actually, x, y, and z. You cannot solve it. So you have to have as many variables as the number of equations, or you have to have as many equations as the number of variables to be able to solve for a fixed value of x and y and z. Now, if somebody says, again the same problem, you have two equations but three variables x, y, and z. So you would need as many equations as variables. So you have three variables, you would need a third equation here to be able to solve them. And again, we are not solving for three variables, it is same as what we did for two variables, but I have not seen any questions being asked in SAT with three variables. If you come across one, we will try solving that as well. It's going to be the same extension of the approach that we have followed so far, but I'm just not trying to overload you guys with too many things, okay? If you ever come across a situation where you have to solve an equation with three variables, let me know. We'll solve in the class. Same approach, but little more cumbersome, yeah? So we looked at composite functions, evaluating functions, and then we looked at isolating quantities, and we looked at two different techniques. Any questions so far?
No, sir.
No. Okay. Now let's look at solving quadratic equation. We have done that enough in this class for the kids who have been there for some time. For some of you who have joined recently, you might not have gone through that exercise. So we can look at this quickly in 2-3 minutes, or let's park that one for today, okay? And I will touch upon the solving quadratic equation in the class tomorrow, and the kids who have been part of that experience in the past, they can drop off a little early tomorrow, okay? So let's say Dhanushri, if she is already tired of solving quadratic equation, she can decide to say, okay, fine, last 15 minutes of the class I will not join because it's a repeat telecast of what I have gone through so many times. Yeah, or vice versa. Or if you want to continue, you can continue as well. So for tomorrow, we'll talk about the solving quadratic equation, at least for Heer, for Ritika, Shravya, Ananya, Arya, Sunarka. Yeah. All right. And Isha, Srivatsav, Atharv, Dhanushri, Vaibhav, if you guys feel like this is an overdose of the same information, you guys can leave little early tomorrow, okay? 15 minutes early. So we'll cover the solving quadratic equation in the class tomorrow in the second half. Now let's look at solving equations algebraically and graphically. Shall we?
Yes, sir.
Okay. Now, and again, trust me, whatever we will learn in next 15 minutes, most of the things you would know. I'm just trying to help you guys connect the dots and be able to relate how these are the same concepts. It's like same content with different packaging. Okay, or as a student, I would want to look at it as two different approaches that we have for solving something. Now let's look at this. Again, my favorite Okay, and the second equation, let's say 2x minus 3y equals to 12. I have these two equations. I can solve them. We just looked at the isolating quantities approach, where we can either multiply this by 2, this by 5, and then add them together. Subtract this equation from this equation, or vice versa. Or we can find out the value of x in terms of y, substitute this value in this equation and solve it. There are two approaches we have. Now there comes the third approach. What we'll do is, I'll take a graph paper and draw this line 5x plus 7y equal to 15. If I have to draw this line 5x plus 7y equal to 15, how will I draw? For drawing a line, I just need 2 points. Yeah. If I have 2 points, I can connect them and that becomes my line. Yeah. So same way, if I have to draw a line on a graph paper using this is a linear equation, right? So it's going to draw a straight line. Linear equation because the power to the variable is 1. If I have to draw this line on the graph paper, how will I draw it? What will I do? I'll pick up the value of x equals 0 and find out what is the corresponding value of y. If I say x equals 0, what is the value of y? Y will be equal to 15 by 7. Yeah? Everybody with me so far?
Yes.
This becomes my first point. X equals 0 and y equals 15 by 7. For the sake of simplicity, I will say 2. Okay? Now, I'll pick up second point. Because for us to draw a line, I just need 2 points. Second point, in the first scenario, I picked up x equals 0. Now let's pick up y equals 0. When my value of y is 0, what is the value of x? 3. Agree? Don't agree? As for the first equation, I'm just dealing with the first equation so far, okay? I'm just trying to draw a line using this equation. What did I do? I picked up, this was my contract as I said. The value of x and y will be such that 5x plus 7y will be equal to 15. This is the contract for this equation. Now, what did I do? I said, okay, fine, I'll remain within the contract. I picked up x equals 0. For the value of x equals 0, what is the corresponding value of y? When x is 0, this becomes 0. So 7y equals 15. So y equals 15 by 7. 2.1 something. So I'm just keeping it 2. Just for the ease of drawing of this one. Second thing, I said, okay, I'll remain within the contract. This time, I want to change the value of y equals 0. When my value of y is 0, this becomes 5x equals 15. So x equals 15 by 5, that is 3. So I got second point. So my first point is x equals 0, y equals 2. X equals 0, y equals 2. Let's say this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2. This is 1, 2, 3, so on and so forth. Minus 1. So this is my x-axis, this is my y-axis. Yeah? My first point is x equals 0, y equals 2. X equals 0, y equals 2. This falls on the y-axis. Y-axis is the one where each and every value of x will be 0. So this falls on the y-axis. X equals 0. This is my first coordinate. 0 and 2. Okay. What is my second point? X equals 3, y equals 0. X equals 3, y equals 0. This is 3 and 0. Yeah. Just join these 2 points and you got a line. This is a line for this first equation. Is everybody with me?
Yes, sir.
Yes, sir.
And can I assume that you guys had seen this before by yourself also?
Yes, sir.
I'm 99% sure that you would have seen it. I mean, you might not be able to recall, but I'm sure you would have seen this. Yeah. But anyways, we are doing that in a simpler way. Same thing I'll do with the second equation. 2x minus 3y equals 12. So I'll pick up first point when x is 0. When x is 0, when x equals 0, what is the value of y? This becomes minus 3y equals 12. So y equals minus 4. This is my first point. what will I do? Again, I'll put y equals 0. Hello.
He did a homework, but he forgot to bring it.
That's okay.
It's okay.
Yeah.
I was also confused, so he was just measuring and write it down. I don't know what to do. And that's the way he was supposed to do.
I'll explain him what he has to do.
Yeah, because he was just measuring that and writing down. Says, no, you're not supposed to do like that.
Not that way. I'll explain him.
That's pretty, yeah.
Okay. You take a chair and sit down.
Sit down.
Let me finish this class, then we'll start your class. Okay?
Yes.
Yeah, any chair is fine. So what I'll do is with the second equation, I picked x equals 0 and we got the value of y equals minus 4. Then I'll put y equals 0 and then that gives me x equals, when y is 0, x equals 12 by 2, that is 6. So we got 2 points, 0 and minus 4, so it will be somewhere here, 0 and minus 4. And second is x is 6 and y is, so somewhere here. Now when we join these 2 points, see, this is a point where these two lines are intersecting each other. That is the solution. This is what you will get by solving these two equations. Whatever you find here, whatever is the x and y coordinate, right, of this point where these two lines meet, that becomes your solution for these two equations. The x coordinate will give you the value of x, the y coordinate of this point will give you the value of y. So this is how you can relate, that you have one linear equation, second linear equation, you can either solve them algebraically or you can draw it on a graph paper and see where they are intersecting. Wherever they meet, that is a point where it satisfies both the equations. Or this is a point where the value of x and y is same for both the lines. That is a common solution for these two equations. That is how you can relate it. Am I making sense so far?
Yes.
Yeah. So look at it conceptually. This is a line. Every point on this line is following this contract. This is a line. Every point on this line is following this contract. Now we are trying to find out what is the value of x and y by solving these two equations. That means that has to be a point which is falling on both the lines, and that is where this intersecting point is that point which is falling on both the lines and following both the contracts, and hence helps us solve these two equations to get the value of x and y. Are you guys able to connect the dots?
Yes, sir.
Yep.
Yes, sir.
Makes sense? So now we have 7 more minutes. So let's look at it conceptually. Okay. So this was with the linear equation. And again, for all of you, right, when you say linear, meaning it's an equation which will draw a line. Linear. In linear, you have the word line. So any linear equation helps you draw a straight line. No making noise. There's a class going on. So linear has a word line, meaning any equation which makes a straight line is called a linear equation. Or for your recap, any equation with maximum power to the variable as 1 is a linear equation. Here maximum power is 1. Maximum power to the variable is 1. That's why it is a linear equation. It forms a straight line. So again, this was extra information. Now let's say you have x squared plus 2x minus 7y. See my favorite word 7 again. Equals 25. And then you have another equation called 5x plus 3y equal to 12. See here, this is a linear equation. This is going to draw a straight line. What is this guy? The first one.
It's a quadratic equation.
Quadratic equation. What does the quadratic equation do? It draws a parabola, right? Now, I'm not spending time to draw the parabola, but again, like a linear equation, if I have a quadratic equation, this is the contract between x and y. That x squared plus 2x minus 7y will be 25. So if value of x increases, value of this guy decreases, or vice versa. They have a deal. Say, okay, if I'm increasing, you have to decrease, or you are increasing, I have to decrease. That's the deal, because the end result has to be this. Okay. So let's say the parabola draws like this. With this equation, you draw a parabola like this. With this linear equation, you draw a line like this. What happened in this case? When we were talking about two linear equations, they were meeting at one place, one point. It was giving us one solution. Here I have a parabola, meaning I have a quadratic equation and a linear equation. It's going to meet at two places. It might meet at two places, right? So it will give you two possible answers. And those answers will be the point where it meets, where these lines, this line and this parabola, intersect each other. So when you look at this kind of a question, let's say somebody says, okay, fine, find out the possible values of this one, and they'll give you a graph. So you just have to look at the coordinate of the points where these two are intersecting each other, and that will give you two answers. If you have a quadratic equation anyway solves for two values, right? If you have a quadratic equation, there is a possibility that you will get two values of x. If you are getting two values of x and that coincides with this guy, those are the solutions that you will get. So in simple terms, you can always solve these two equations like in algebraic way and find out the value of x and y, or you can draw the graph using these two equations and see where they are intersecting or meeting or crossing each other. And those points of intersections are nothing but your solution for x and y based on what we have seen so far. Any questions so far?
No, sir.
No? All clear?
No, sir.
Did we learn something or we did not?
We did, sir.
We did? Okay.
Yes.
Okay, all right. So again, trust me, my interpretation from this class is there's nothing new that you guys have learned. I have just helped you collate things and build a conceptual understanding around that. Okay. So when you have a problem to solve, you can always think through it and see which option is faster for you. Let's say you have two equations to solve. Now you know that okay, I can isolate and solve, or I can kind of do some magical trick by multiplying, dividing, and then kind of look at how do I knock off one of the variable so that I end up getting one variable, one equation, and then I can solve it. Or you can say okay, fine, I can even try plotting that graph and see where it intersects, and that is what my answer would be. Yeah. So that brings us to the end of the class. For the senior kids, okay, I know some of the junior kids have joined.